now that we have get node taken care of, we need to use it to actually make our to make our adding work. So we want to put adding at index, right? So what is the best way to do that? Well, we can assume that we can grab, let's go ahead and set variables for index -1, index, and index +1. And I'll rename them when I actually am done, but we can use getNode to get these guys. So first off, let's see. Node E, actually I won't need to rename them if I do it like this. Node E before is equal to get node at index -1. So that will get this node. So this guy would be before. Node E, let's see, not call it current at index, but maybe, yeah, middle is equal to get node index. And node E after. Now, 3 of these are going to go away. In the sense that I'm not going to use 3 of these variables, but they're good for doing our thought experiment about how this works. So let's go ahead and say that I have this adding node over here, right? Now, first off, I have to do this in a specific order, which is the specific order that hopefully you picked up on when we were seeing add, which is that when I'm adding a node, the first thing I want to do is attach the node I am adding. Otherwise, we get into that problem with the garbage collection, right? If I simply just grab this arrow right over here and point it to here without, and that's the first thing I do, then I am in, as they say, deep doo-doo, because everything at index and afterwards is about to get dropped. It's about to get dropped like a call from AT&T. So, let's go ahead and see index -1, right? If we do that, that's just not going to work, right? That's going to be really not good, right? We will lose, the garbage collector will come in and take care of everything there. So that's not good, right? So we have to attach our node first. We need to attach our node where? Well, we want to attach it between index -1 and index. So we don't, would pointing it here work? Looks like it. Pointing it here, that wouldn't really be what we want, right? If we're putting it between these guys, then his neck should be the guy at index. It should be middle. And it shouldn't be this way, because otherwise we get into this kind of circuitous kind of thing. So we would want to attach it for middle. But the question is, do we really need all these variables? So first off, after might not actually exist, right? Index could be equal to size, and if we try to get something at size +1, this is going to give us a null pointer exception. So if we have this, if we try to get after like that, we are going to get a null pointer exception possibly. So we're not going to use that. Middle, by the way, we don't really need to keep track of middle either, as it turns out, because middle is the same as before.next. And we don't want to grab the guy at the area we're inserting, because if we just simply were to grab middle, right? If we were just to grab middle and not to have before, right? This guy over here is middle. If we grab him, then the only pointers we can manipulate are our addings next, and this one over here, and this pointer over here, which doesn't do anything for us. So instead, what we're going to do, so we don't need him. Instead, what we need is before. And I'm not going to use middle because I want you to see the way this is going to work, the way this grammar works, because this is our first, this is the first real place you can trip up. So let's go ahead and I'll delete this, right? We know this is index -1 over here, but we've given it a new name, right? This is index This is index plus 1. Right? We want to insert over here, and this guy, we're going to call it before. Although I don't know why I'm referring to the nodes as guys. I'm pretty sure they don't have any particular gender. Okay. So before is this node. So we need to do the following things. The first thing we need to do, if we draw, and the way I always like to say to think about it is get out some pencil and paper and draw it if you need to. And then write what you need. So adding dot next should be what? It should be this node, which is what? It's equal to before dot next. So adding dot next is equal to before dot next, right? So the node before the node that's before the index we want to get, right? That's why I call it before. The node before the index I want to add, before the index I want to add at or insert at. So before dot next, the current index I want to add at, its memory location is going to get stored at adding dot next, right? This resolves into a memory location, but this is a variable, right? We are storing this variable before dot next in this memory location. So now that we've done this, this is our current linked list. Now, the next thing we want to do is the following. We need to take this arrow and move it over here so that we get this. We need to take this arrow and move it over here. So what is this arrow? This arrow is attached to before, so it's before's dot next arrow, right? Before dot next. And what are we pointing it at? We are pointing it at what? We're pointing this arrow at adding. So we store the memory location of adding inside there. So 3 lines actually. So before is equal to get node over here. We say adding dot next is equal to this node over here, before dot next. And then we say before dot next is equal to adding. Okay, so that is, it's really short, although a lot of thinking had to go on for there. So what if, though, so now we have to ask ourselves, though, of course, what if this is null? What if before is the last node, right, and we want to add at index size? Well, this still works. We get the last node, which is before .net, which is before. It's at index -1, so that's perfectly valid, right? This would be the last node if we're adding to size, right? Say this was, to give a concrete example, say this is a size 4 linked list. I want to add to index 5. So this is 4. We want to add to index 5. So we get index 4. We say adding dot next is equal to before dot next, which is null. And then we say before dot next. So we store null in adding dot next. We won't even bother drawing the arrow there. Then we go before dot next is equal to adding. So now we've increased that. So that seems to work, but we need to actually prove that it works. So let's go ahead and write ourselves a toString method.